Okay, welcome back. What I want to do is continue with DC motors, but I'm trying to provide as much information to you as possible so you have an opportunity to look at it from different angles and different perspectives. Okay? So, let me just make sure I can get this off. Okay. 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 I'm looking at, let me just make sure I can get this into place. DC motors, okay? Now here we're looking at the effect of magnetism. As you can see, light poles repel, north to north, south to south repels, but unlike poles attracts, okay? South and north, north and south. Okay. Here we're showing you the magnetic field, north to south, okay? Don't need me to have much on this, to say much on this actually, basically, okay? And here we have electric currents, magnetism. Now here in A, you've got the current flowing round, but you've got current flowing upwards, okay? Here we're looking at now for me, I'm looking at the right hand rule here, but we should probably pick that up in a moment or so, okay? But don't hold me to it. But here you can see that in B, the current is also going vertical, okay? Here we have the right hand rule, magnetic field, sorry, okay? And what you're assuming here is that we're holding a conductor and the current is flowing downwards into the conductor, okay? So remember the right hand rule. Now again, make sure you're familiar with this for yourself. Do your own research. Look up additional information to make sure that the information provided is correct, okay? Do not take it as face value, okay? Electromagnetism, okay? And here we have the current flowing around the conductor as the conductor moves within that magnetic field, okay? It induces a current. Even if you do it by hand, you will still induce a current, even though the current will be very small, but that current will exist. Okay? Here we have an inductor, okay? Any coil of loop of wire can be referred to as an inductor. Electromagnet, or an electromagnet if you prefer. Here we have current flowing into a coil. Basically, this is a coil. Okay, you can see that the magnetic field created around it by that induction of current. Now we're looking at force in a conductor. Here, positive current flowing. You can see that the force exerted on the conductor within the magnetic field is downwards, okay? So the force on the conductor is exerted downwards. B would represent your flux density, okay? Obviously there will be more flux density than here, but this has been simplified to show you purely for illustration purposes, okay? And again, here we're showing you force in the conductor continues, and here when we turn the polarity around, we change the direction of the force. And again, V flux density, north and south. and current flowing through the conductor the other way, but the force now is upwards, okay, by changing the polarity. Here we have a diagram of a simple DC motor. You have the armature, you have the force being exerted upwards, and you have, as it would rotate and come down, the force being thrust again, forcing it downwards, causing the motor to rotate. These are the brushes, okay, voltage source, whichever the voltage source you wish to apply, but that would be the idea of it, okay. And here we have simply moved away the motor itself and leave us with the commutator. These wires to armature coil, these are the wires going to armature coil, commutator, okay. These would be your commutator. Here are your brushes, okay. And here we have an electric motor, okay. And all I'm going to do now is to delete it, remove piece by piece. So here you can see your power source, okay, going to your motor, feeding the motor from either side. Here is your brushes, okay, in contact with the commutator, okay. We have now removed your outer stator shell, and here you have your armature, okay. Here you have your armature, okay. You have your commutator, you have your power supply. You can see that current is flowing through there, forming a circuit. Okay. Now, I've now removed to look at it as a single piece, single copper conductor. Okay, so we got current flowing through. Okay, and let's see what happens now. Okay, and there we are. Okay, and we can rotate it rotate it, rotate it, but rotate it. Sorry, rotate it. I'll get my teeth in later. Okay, but you can see that we have a source there. Okay, and let me see if I can get it to rotate faster. Okay, it does, and there you are. It's simply showing you the connections that it made that causes the current to flow, and you can see north to south here. Okay, let me see if I can go back. Can I go back? Can I inch back? Let me see if I can inch back. Can I inch back? I'll try and see if I can inch back. Yes, I can inch back. Yeah, and it's just showing you the forces on the wire. Okay, magnetic field. Okay, that's your magnetic field here. Okay, forces on the conductor. Okay, on both ends. Okay. Okay, I'm just going back a little bit, stepping back. Hopefully. Okay, yeah, and I'm there. That's as far back as I want to go for now. So we can continue with that. Okay. Okay. All right. Okay. A little bit ended a little bit too fast there for me. So let me just review this again for a second. Okay. And I'm just going to recap with you for a moment. Okay. Okay, there we are. Okay, I'm just going through this again just to recap because I think it might have run a little faster than I expected. Okay, so I'm taking a little time now to recap. Okay, and thank you. I hope you found this useful. Have a good day. Bye bye.